Okay, we're going to look at our homework for today. So I called this FRQ one-dimensional kinematics, but the last problem actually has momentum in it. But what these three problems have in common is the three problems all have to do with resistive forces. So we're going to go through this step by step. So it says a ball of mass M in cross-sectional area A. So now the cross-sectional area is going to create drag. Is released from rest near the surface of Earth. The ball experiences a resistive force. So first of all, once we see that it's a resistive force, you know it has to do with calculus. Due to the air that is proportional to the ball's velocity. So this F, the resistive force, is equal to minus VAV. And this V, so the negative sign, and this is going to have to do with the free body diagram. If I'm calling down positive, this is negative because the resistive force goes in the opposite direction. So it says draw the free body diagrams for the balls in the following situation. So first of all, a short time after the ball is released. So a short time after the ball is released, it hasn't reached terminal velocity. So the weight is going to be greater than the resistive force. So remember, they do the little boxes now on your free body diagram. So remember that the weight has to be greater than the resistive force. So you see how I made this arrow 2 boxes and I made this one 1. Okay. On this one it says once the ball has reached terminal velocity. So remember, terminal velocity is the fastest possible speed, so that means the acceleration is 0. So when it reaches terminal velocity, that means the forces are balanced. So now I'm going to have my force of weight the same as there. And now I'm going to have my resistive force. They're going to be balanced. Okay. So now it says calculate the terminal velocity. So if I want to calculate the terminal velocity, again, the forces are balanced. So I'm going to do what I always do. I'm going to, use Newton's second law. I'm going to call down positive. I'm going to say summation of f of y is equal to ma, which is 0 because the acceleration is 0. So when I look at my free body diagram, I see I have f of g, which is positive, minus f of r is equal to 0. Now I'm going to remember that's what my resistive force is. So my weight is going to be mg minus BAV, and I already have that is equal to 0. So since I want to solve for V, I'm just going to rearrange the equation. So I will put that on the other side. mg is equal to BAV, and I want to solve for V. So mg over BA is equal to V. So that's my terminal velocity. Not bad at all. Starting from Newton's second laws, derive an expression for the time required for the ball. So they're telling you you're starting with Newton's second law. So the first thing you need to do is write down, all right, F is equal to ma. But now it says for 1/3 terminal velocity. So now I'm ending up using this diagram. Okay, so when I do that, again, so now, again, I'm going to have Fg minus Fr, but now it's going to be equal to ma. So then I'm going to have Fg minus BAV is equal to ma. Now, I want to solve it for like 1/3. So we're going to end up doing calculus. All right. But before I can get the differential equation, what I have to do here is mg minus b AD is equal to m dv over dt. So now, and remember, you'll then substitute back in here that vt is equal to mg over ba. So you'll take this and substitute in here. This is, remember, we have to separate the variables and all that other stuff. So I'll let you guys do that fun calculus. And then this is typical. This is acceleration versus time, and this is the velocity versus time. So remember, you want to kind of put on here, well, what is this? You know that that is, when I end up doing my graph, again, whatever my asymptotes are. All right, so I set up number 1 for you. Number 2 is also kind of resistive forces, so I'm not going to set that one up. And it asks a lot of questions. All right, so number 3, it says a crash test car. So they give you the mass, moving at a constant speed, collides completely inelastically. So now you know I'm going to do conservation of momentum. It was initially at rest. And then they give you something. As soon as you see the word function of time, that means calculus. So if they're giving me the velocity of time, they're probably going to ask me for the position, where I have to integrate, and then they're going to ask me for the acceleration, where I'm going to have to do the derivative. All right. So calculate the mass of the object. So this one, again, I have to do something with conservation of momentum, like P naught is PF. So you have like the mass of the car moving at some initial velocity, then it hits the truck, which is at rest, and then that's the mass of the car. Well, it's not a truck. They don't know what it is. M times VF. So they tell me that V is equal to 8 over 1 plus 5t. So what you do is you take this, V is equal to 8 over 1 plus 5t. T is 0, so 8 over 1 is 8. So you put in 8 here and then you solve that. So that's pretty easy. And they gave you numbers. Assuming the initial position, determine an expression for the position. So again, they want the position as a function of time. Velocity is a function of time, position, so now I'm going to integrate. So again, x is equal to, and then you put that, you're going to integrate 1 plus 5t dt, so you guys can do that fun stuff. Determine an expression for the resisting force of the car object system after the collision as a function of time. So the resisting force, it's a force. And if I want it as a function of time, that means calculus. So anytime I see the word force, F is equal to ma, calculus function of time, so m is equal to dv dt, and that's it. So then you do that. And then the last part, impulse. So impulse is equal to the change in momentum, and impulse is j. And that's always equal to m delta v. So what I would do is I would do the velocity. They want it between 0 and 2. So do the velocity at 2 and the velocity at 0 times the mass and find the difference. And that'll give you the impulse. I mean, there's another way you can do it, but that's the first way that I thought to do it. But I know there's another way, and I won't say. Some of you might do it that way. And that's it. That's the homework. So this is from AP Classroom, and we're going to be doing these FRQs because they might be similar to maybe the ones on your test this year. We don't know. We'll find a little bit more out. So, and that's it. And don't forget to turn this in before noon, whenever the date's due. That's it.